live. Welcome to the live stream, everybody. This is actually starting pretty late, so I don't really expect too many people to be actually watching this live. Boy, do I need a haircut. Woo! Getting bushy. Anyways, I don't really expect too many people to actually watch this stream live. I don't expect too many people to watch this live stream live. So you might ask, why am I doing a live stream if I don't expect too many people to watch the live stream live? Well, because that's all I got right now. Computer's still out. Computer's going to be out for a while. That's just all there is to it. Finances are fun. They're not. I'm being facetious. But, yeah, so that's all I got. I figure we're better off having something than nothing. Alright, so, that out of the way, let's get some refreshments going on here. What do I want to use to open this today? There we go. Good old fashioned. So, hopefully you guys are having a great day and you're coming here because you want to know what in the world we're up to. That's a good thing. I want to know what in the world we're up to, too. I kind of want to know that. It'd be handy information, wouldn't it? Anyways, I have a couple different avenues I got to take on here. As far as we still have all this set up the way we left it. The motor driver circuit does work. I've learned a few things, such as on a Triac, you have to drive the right side. You have to drive the gate from the right side of the, you have A1, A2, and the gate. And apparently you have to take the voltage off of A2 to drive the gate, I guess. I'm not an electrical engineer. I did not know that. Now I do. So, here is to having a good night. Arc Devil, bro, this is fake. This is only juice. It is, well, it's hard juice. This is not actually beer. I'll say that. I make no presumptions? Assertions? I don't know. It's not beer. It's Angry Orchard and Fireball. It's my apple pie. Alright, so let's go over the things that I actually want to accomplish. The zero cross detection circuit. It works. It actually works pretty well. But I kind of want to modify the end stage. So on the zero cross detection circuit, I know... Hi babe! What about electrostatic equations? Yeah, I don't know any of those. I am, look, honestly, the entire point of my channel is to just show that the average person can do more than we're led to believe. Just, that's kind of what it is. I'm just an average person. I don't know electronics. Anyways, so yeah, our zero cross detection circuit, it actually works pretty well. Everything about it. It can be, and this is one thing I actually kind of want to try, is those circuit creation. If you ever watched any of the other, electrical engineers, YouTubers, electronics YouTubers, they always advertise these things where you can get circuit boards made for you. I kind of want to try that with this. Knowing that the circuit works, I kind of want to try that. But I want to modify my end stage because I'm not very happy with how what was I having to do? Oh, I was having to dump a lot of resistance in there in order to get the voltages to actually register. I think if I change the resistance to the ground side, I think that'll work better. So that is something I want to modify. So let's just go ahead and start doing that. Now, this opto isolator is a transistor-based opto isolator. What that means is that it is directional, whereas the opto isolator on our Triac driver is a a optodiac. The one on here is a transistor base, so it's definitely directional. All right, so the things I'm going to need, we're going to start by desoldering. Do I want a different tip? Yeah, I'm going to use a different tip. We're going to use a bigger, fatter tip for this. And, yeah. Because it's directional, I need to, just be sure that I keep that in mind. I love this soldering iron. I have to do a video on this soldering iron. This thing, it's the TS101 soldering iron. This one's by Miniware. There's several different makers of it at this point. This thing is fantastic. Not only does it use high-end tips, you can power it with many different ways. Right now I have it on a 110 volt brick. But look at this. I just turned it on to 330 degrees, and you're not going to be able to see that well, but the thing, it's already at 250 Celsius. We're reading Celsius. I think this thing's fantastic. I cannot get enough of it. All right, so let's do a little tip tinning action going on here to prime our suckage. And we're just going to start desoldering. The reason I'm desoldering is because I want to... There we go. I kind of want to save the mess. I don't want this to end up a giant mess. So that's what I'm attempting to do, is to save the mess. Maybe I should bring out the helping hands. That's not a bad idea. Clamp it. And Jed, clamp it. Now, give it better weight distribution. And that's a little better. That didn't work at all. Maybe I do need the other tip. Oh. Yep, that's not working. Ha! Tip change. Live. Beat that. Ah, this viewing indicator is right over a white thing, so I can't see. Just change the tip live on this thing. Beat that. Yeah, I highly recommend this. Highly. Oh, so let's just think about, while I'm doing this, how do I want to do this? What I want to do is put the resistance on ground. And switch the power. The idea being, it is much easier to bring it to a full 5 volts if we're switching the power. Why are we not getting good suckage? Yeah, this is not going as well as it could. So in other words, if I have the resistance on ground and I add power, it'll jump up to power, to source voltage. So if I want the top end of the wave of the pattern to be 5 volts, I apply 5 volts through the switch to the sensor, then to ground, sensor pin, then to ground, and my power will overcome the resistance and maintain 5 volts. At least that's the idea. Wow, this is not... Why is this not going well for me? You guys ever watch those videos with those little cheap DIY videos, and they're using like the ugliest soldering iron tip that you've ever seen, and like it just bugs the hell out of you? It bugs the hell out of me anyways. Alright, let's see if I can... I do need to make a stand for this, but let's see if I can take apart some of these wires yet. Nope, we're still pretty soldered in there. Alright. Let's take the temperature up a little bit. See what we can get. I do have a fan blowing on me. Maybe that's affecting my desoldering. Doo-doo-doo. Come on. Usually this works a lot better. But today, I guess we're just not feeling it today. Let's try the solder wick. Doo-ba-doo, doo-doo-ba-doo. The one thing I don't like about solder wick is how much it dries out your solder tip. We're at 350. And do shit. All I'm getting is the solder off the tip. Romulo, message retracted. Okay then. I am not having good desoldering luck today. Frustrating. This is actually the tough part about doing live streams for stuff like this. It's like the things they don't show you on the edited videos. Like making a video entertaining it's not easy. It requires a lot of footage and a lot of editing. And that's two things, or at least one big thing I'm not capable of doing right now with the computer being down. So we're doing it live, and man, I'm here to tell you, 90% of the footage, I'm just throwing this number out here honestly, but I feel like it's around 90%, somewhere between 50 and 90% of the footage that gets recorded isn't usable. Like, unless, I don't know, maybe I'm just not that good at it, I guess. That is certainly a possibility. Why are we not... This really doesn't feel like it's working right. I should be getting much better desoldering action. I might just have to cut all this out. It's not even melting solder. Where's my solder? Am I just missing something here? The fucking soldering iron works. So why am I not getting nice wet on the board? Okay. Yeah. All right. Starting to get a little frustrated. I don't know. But this is frustrating me. Get some tip tinner in there. Do that up the tip. Let that cool off. Okay. Now what? Alright, I don't want to damage the circuit, but I don't care about the jumpers. I had a little bit of success in here. Let's see if I can mess things up a bit and get this thing taken apart. Okay, now here's the deal. I want to put a resistor in here. Right. This is not going well. Hi, Pokemon Girl. That's what he said. I'm pretty sure Rupa has one line. Anyways, all right. I guess I put this away too soon. Ooh, what if? Aha! Let's use the nuclear option. Come on. There we go. Butane for the win. Yeah, we'll get it hot now. You want heat? I got your heat right here, baby. At least I think I do. Hopefully I don't damage the circuit board. Is it going to work? Is it going to work? Is it going to work? Hey, it kind of works! Hey, wait a second. Don't I have a can of Airsom here? Somewhere? I do! Aha! Let's see if this works. Alright, get nice and hot. Oh, yeah. Heat the can of air up. Don't do that at home. Get hot, get hot, get hotty, got it hot. Get hot, get hot, get very, very hot. Uh-oh. Do 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 do. I don't want to damage the circuit board, but it might. That was a good chunk of solder. Nice. All right. Let's see what I can do with that. I think a 1K resistor should still be good for this circuit. But, nice! We're just going to take that one completely out. So pull this up. Take that out. And that out. Ta-da! It's not the prettiest thing in the world, but it gets the job done. Okay. All right, now, back to my plan. I want to jump here to there, right? So the pathway is this way, so I kind of want to move that over. That would work better if it was moved over. It would. Can I move that over? Maybe. Drink time. All right. Let's see if we can move it over. Sort of. It sort of moved over. I mean, technically it moved over. I got it pulled out. I think we can put this back in. I mean, come on. Worst case, I can just put a new header in. That's not a big deal. If this doesn't go in right. Okay. And I want this to be on row 15. Oh, yeah. Oop, no. Careful. Really? I just said be careful. That was my super gravity moment. Oh man, my tape came off. I have this tape. Oh, whoop. Too far. Back up. That should work. Had this tape covering up the light above the phone, so now the phone's a little bit glary. Guess you'll have that on these big jobs. Ooh, it's not the prettiest thing in the world, but it'll do. Okay, now I want a 1K resistor from here to there. Right. And then I want a jumper from here to there, right? And a jumper from here to there. Okay. Jumpers right here. All right, now I had a green and a green. Let's see if that still works. Although, I kind of want to use different colors. I mean, whatever fits. Whatever fits, fits. Yep, green fits. Green fits very well. So that's what we're going to go with. All right, fold that up to here. Fold this one up to here. Okay, that's to that pin, right? Yep. That's to that pin. So 4N25 opto isolator. Okay, yep. And then we want to append to that. Same way. Right? Again. Take this to here. Good. And then take this side to here. Good. Good. Okay, so far so good. And then I want a 1K resistor. All right. This actually kind of stinks. I'm a little upset because the live streaming setup I had before the computer went bad, the live streaming I had set up, I had a whiteboard where I could like draw things out. That'd be so handy for like showing you what I mean when I'm talking about these things. Okay. Give me that. Alright, a 1K resistor should be fine. The difference is, let's see, the difference with the amount of resistance that I put in there is the amount of current that it's going to draw on the 5-volt rail. So, if we want to know the amount of current, so let me think. Going to ground, the resistance doesn't matter. So, I should be able to put a 10K in there, and it should perform the same as a 1K. When the circuit opens, it will cut off 5 volts, taking the sensor pin to ground. So at that point, the resistance doesn't actually matter. I mean, it does, but it doesn't. Yeah, so the 10K should pull it down fine. But it will, the 10K will limit the current capacity when the switch is on, which is the bigger deal. So, let's do a 10K. And I'll pull up my stack of resistors that I never cleaned up from the last time that we did this. Oh, here's a 10K. Ta-da! 10,000 ohm resistor. Now, I could be wrong. And I could be doing this completely wrong. Definitely could. Or not. You never know. Actually, no, some people do know. Some people are like engineers at this stuff, and they actually know a great deal. You know what? How about I bend this a little closer to home? Bend it here. Right. And then bend it here. Okay. So right there and right there. That puts the resistor, and then that gets taken over to there. Alright, that puts the resistor to ground. Now, what that should do is that should cause enough resistance that when the switch makes, the voltage should overcome the resistance and bring it right to 5 volts. And when the switch breaks, because it's an opto isolator, and transistors can rob power. So the gates of transistors can bleed power over, but since it's optically triggered, we don't have any other voltage sources. So when the circuit opens, when the transistor opens, it should drain through the 10K ohm, should drain any residual voltage, but take it to ground. So the sensor pin goes to ground. That's what should happen. Let's solder it up and test it out and see. All right, solder, bit tenor. Good. Let's do it. And we take a drink while that warms up. Put a helping hand in there just to give it a little more steadiness. That's fine. Yes, sir. Ta-da, all warmed up. Good to go. All right, let's tin this tip. Okay. And get our solder ready. Ta-da. Okay, let's try it on this side. Ooh, that one got a little bit messy. Try it over here. All right. Good. Good. Bend this up. Out of the way. Uh-huh. Well, the desoldering didn't work out too well, but the soldering's going smashing. Good. All right. Here, soldered to there, bridged over to there, turns on, goes to here, over to here, so that goes to 5 volts, and ground with the resistor, pulls it down. All right. So, soldering went fine. I don't know why it wouldn't desolder. Again, possibly because I have a fan blowing on me. That's not great. Holy smokes. Holy smokes. I am full on Butterfingers today with a hot implement. Flush cutters. Let's trim this up. All right. Trim this up here. Right. Trim this up here. Trim this up here. Okay. Now to confirm whether or not that actually works. Okay, I need to, in order to confirm whether or not this works, I need to give it power here. Alright, I need to give it ground here. Right, I need to give it 5 volts power. Is that this one? Sort of. I don't need to go through the resistor anymore. Alright, 5 volts. There. Now, I can put this on sensor pen, right here. And I don't need to start the whole circuit up. I need to give it power, but it doesn't necessarily need to start the entire circuit. Let's see. I need this one. So, ground. What was I using for ground? Oh. Because I'm using that one. Oh, that's fine. Yeah, that's fine. I can use the Tektronix because this is all low voltage that we're measuring. But do I want to do that? No. I want to use... I can't do both. Biscuits. Why not? Why not? Because there's a ground. I can't short out the ground. I'm going to have to think about that. Oh, that's when you need those isolated units. Well, if we put it on a transformer, I got to think about this. All right, so I can use the Tektronix on this to confirm whether or not we are getting that signal. So that comes to there. I don't really care about that. I do care about this. I need an an isolated 110 volts. That's what I need. If I put it on a transformer, so that the transformer reads neutral, so if it's a 1-to-1 transformer, then the transformer will be 110 volts, but it'll be electrically isolated. So then I can do the testing without worrying about it shorting everything to ground. That's a thought. I'm going to have to look that up. Alright, I do need to plug this in. That's in the off position. Let's plug in our power. Screw it. I'm going to use the big scope because I like it better. And I'm making a mess. Of course I'm making a mess. It's what I do. Alright. Okay, so I want to use ground. Yes, sir. Alright, so we got grounds right here. Alright, ground. And you know what? This one doesn't even matter. Okay. We'll set that to the side. Right. Channel 1. I wish these leads were a little bit fatter. That should do it. All right, channel 1 right there. All right, so that's the feedback. Yes. Okay. Pull this over here. In fact, take this off so that doesn't get crossed up. And I have 110 volts to that. Okay. So, you know what? If I had a sine wave generator, that would be ideal. Oh, this one came off. That's what happened. Yeah, that needs to stay on. Right. So pull that over here. Okay. So that stays on. That stays on. These get pulled. Not doing anything with that. So all we need is the signal reference. In fact, I'm going to take that off so that that doesn't carry over to any... You know what? I don't even need this. I can just put this straight to here. Right. All right. Okay. Let's get the oscilloscope set up. And why can't I do ground to that? If I just do... If I have my polarity correct, I should be able to. But if I don't have my polarity correct, it'll blow up. I don't need any more blowing up. But if I had my polarity correct, ground to ground would not be an issue. Ooh. I could use a multimeter to measure potential difference. Possibly. I'll figure this out. For sure. Alright, the other thing I want to do. I am still bent on turning my Arduino Mini into a 80Tiny programmer. I am bent on that. But these pens are so small. I'm going to have to like custom drill a circuit board for this. God, that's going to be nuts. Bonkers even. Alright, take these off. So they're not handy. But I mean, come on, that'd be cool as shit to have a fucking programmer. Little tiny programmer like that. Arif, ground, digital. Ah, yes. Reset right there. Yeah, I think that would work. It'd just be difficult to make. It would be cool, though. Alright, here's the scope. Lab scope. 4-channel lab scope. Rightio. Okay, I got channel 1. We're high, so let's go. I'm just doing 5 volts. That's 5 volts total, so let's do 10 volts. Back. 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 Okay. Double check, double check, double check. Let's plug in. Give us 5 volts. Alright. We still got nothing there. Nothing on that pin. Right. Because right now it should be grounded. Because that's not on. Alright. Give it power. That's not right. That did not do what I thought it was gonna. Why? It is not going to the full 5 volts. Why? Well, let's see what the input's doing. What 5 volts, right? Yeah. I mean, we got a signal, so that much is cool. We just don't have the signal we were expecting to have. Okay. Give me channel 2. And what I mean by we don't have the channel that we're expecting to have is it's only going up to... Let me take this to... It's only going up to maybe 1.5, like 1.3 volts. And the positive should be like a straight 5 volts. So let's turn on channel 2 and see what our positive... back... Channel 2, display. No, that's at 5 volts. Oh, buggers! The only thing that could indicate is that I have high resistance on on my opto isolator that my opto isolator actually has. And we're down to, is that 9 or 0? I think that's a 0. Turn this. Yep, that's a 0. We have 0 viewers. Yay. Never did I think I was ever entertaining. Alright, so that would indicate that we have high resistance on this opto isolator. More than 10,000 ohms. That's not right. I wonder if the backside of that opto isolator is getting energized enough. Could that be it? Am I getting enough output on that? I may not be getting enough output on that. Let me think. I definitely have high resistance on this opto isolator. I shouldn't be having high resistance on the opto isolator. So, like, you know what? I can confirm this. If I take my ground and I give it an extra umpteen million ohms of resistance, that's to positive. Oh, then it doesn't do jack shit. That was not it. Alright. Okay. Oh, yeah. Why? That is interesting. Why? What if I just do an extra 1,000 ohms? Let's take a 1K here. 1K, right? Yeah. What if I just give it an extra 1,000 ohms? What does it do then? Okay. Yeah, the 1,000 ohms didn't make much of... It brought it up a little bit. It brought it up to like 1.5 volts. Yeah. Now I want to know why I have so much resistance on the opto isolator. It's not dragging my input, so that's good. So yeah, it's just a ton of resistance on the opto isolator. But why? It could be the input. Alright, so I'm going to take the voltage off. The high voltage off for now. Because I kind of want to look on the back of this thing. Right. Is that dirty? So it should be... That resistor goes to there. And that jumps up to there. Is that the positive or negative? Nope, that's negative. That's ground. Wait. Is that backwards? That's not backwards, is it? Now I need to look it up. That might be applying voltage backwards on the opto isolator. Ground. I have a resistor going to ground. Oh shoot, where? It's on the phone. All the information is on that phone. Gah! Not having a computer sucks. All right. What do I do to solve this? Oh, I have another phone up here. So I can look up the data sheet on the 4N25 opto-isolator. Data sheet, which should give us the connections. Oh yeah, no, I think I got that backwards. I genuinely think I have the opto-isolator backwards. Right. So I have... Right, the positive side is here. And... I almost need to... So that's the negative side. So that jumps over to here. Right, that's negative. Jumps over to here. So that's negative. That's negative. This resistor goes to here. That's negative. It is. It's bloody backwards. How the fuck is it working if it's backwards? Oh, bother. I mean, that would explain the high resistance for sure. But it does not explain how it's even working in the first place. Yeah, I got a positive pulse, comes off of here and goes to here. I need to hook these up in a different direction. Goodness gracious, great balls of fire. Okay, that is going to force me to put this diode, this resistor differently. I can put the resist. Realistically, I can plant the resistor right here, which would actually help to insulate against those pins on the back side. So if I put the resistor on the back side, I can jump up to here. This side doesn't matter. It's not connected. And then put this up to there. Looks like I got some more fixing to do. Yay. Am I right? Yeah, why did I think that needed to be grounded at the top? That doesn't make any sense at all. What is that? That's a red, red, brown. This is embarrassing. Yes. Okay. More fixing of my stuff. Yay. So far we're batting 1,000 on fixing of stuff. What is this? This looks like it could be the right resistor I need. I don't think that's going to work right there. Red, red, brown. Red, red, brown. Okay. Oh, how unfortunate for me. More desoldering. All right. You are so beautiful to me. Turn the fan away, so hopefully that's not messing us up. Solder sucker. This is just disappointing. What I do with my wick? What did I do with the solder wick? I lost it. There it is. It's in my mess. All right. Okay. That should be helpful with that. That should be helpful with that. Dang it. Missed it. Nope, that didn't work. Okay. To me. Yeah, it's still not working all that well. Somewhat frustrating. Huh. Man, that's crazy. Yeah. Figures. Oh, goodness gracious. Again, not really working all that well. Desoldering sucks. Okay. Alright. Now I think I can pull that out. Maybe? Nope. Ah, knife. Oy. Perfect thing to drop. Let's go ahead and drop the knife. Yeah. Great idea. No, this thing is just on there way too much. Proof positive. If you don't want to have to redo it, do it right the first time. Oh, nope. And I just bent over the damn chip. Oh, I am not doing well. Nope. Not really doing this well at all. Alright. I guess... You know what? If I can pull this other one off... Maybe I can... Okay. I'm very doubtful whether or not this is going to work. Yeah, because most of the insulation for that is gone already. It needs to go to that pin. It can't cross over that. I could do this either. Oh, this is tough. This is very tough. If I do this on the other side, there's a chance that'll work. Well, I guess let's try it. Ah! Okay. Did it do it? I think I did. Huh. I'll be very surprised if this actually works. Really? Okay. Let's see if that works. Yep, we're good. Alright. Now, I have positive going to the top, ground going to the bottom. I don't know what I was thinking before. Also may have just completely fubbed up that resistor. But if I did, I'll just replace it. But yeah, this is the ground side. Okay. Let's set all this back up again. How you guys like my new water pump? Out of a coffee maker of all things. Okay. Put this up here. Put this here. Right. And okay, we need ground. Right there. And we need signal. Yep. And power. Ta-da! And I'm going to take this ground to actual ground. Okay, and then I need power. Why did I turn my scope off? Whatever. I thought that was going to take longer. We'll turn it back on again. And drink some more. What's up, Ray Ray? PC boards conduct seed very easily, so you should have the soldering iron on the PC board maximum 2 seconds. I think you meant heat. And PC boards are actually fiberglass. So, I mean, that's kind of debatable, but I'm not one to argue. Okay. Boot up, boot up, boot up. Boot up. Why do all my oscilloscopes take so long to boot up? Ooh, I forgot which one I was doing. Nope, that should be fine. Yeah, that's A2 to gate. That doesn't make sense. Yep. Once the PC boots up, we should be good. PC, the oscilloscope. Once the oscilloscope boots up, we should be good. It's thinking about it. It's thinking about it. That's all I'm waiting on, is for that to boot up. While I'm waiting on that to boot up, let me try. Those are kind of bent up. I want to see if a PC jumper pin works well in this little micro, in this little mini piece. It does. So if I drill the holes in a PCB I could do one of those scratch PCBs, drill the holes, solder all these little... Ooh, God, they're so tiny, though. Man, that's going to be tricky no matter how I do it. Scope. 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 All right. Okay. Uh-oh. I think I broke it. Yeah, she's not doing anything. I think I broke it. Boggers. Yeah, she is not triggering at all. Okay. Alright, what I need to do is... I'm going to reset this up. And I'm going to take the... Oops. I'm going to take that out of the picture. Take this out of the picture and just work on this. So... let's see. This pin should be ground. Yep. Alright, so this should be ground. And then I should be able to see... But that pin is ground. Why do I have two ground pins? Did I get mixed up as to what plane is what in here? Is that what happened? Sure seems that way. Yeah, because that's ground. Okay. Right? Yep, nothing. But if I go to here, I barely get anything. What about to here? Did my circuit break? Oh, no. Oh, no. This is on, right? Alright, so this should be 8 volts at most. Wait a second. Oh, this... I messed up. I messed up. Why did you go back to 400 volts? Good God, well, damn thing. 5 volts up, 5 volts down. Okay, let's try this again. This should be ground. Yep. What is this? Ah, that is the pattern that I want to see. That makes about as much sense as a fart in a spacesuit. What? How is that going? Oh. It's alright. Trace 1. Do not AC couple. That's even worse. What the fuck? Is it because I'm not reading that to neutral? No, it shouldn't be relative. I mean, I get the pattern I want, but why is it in the negative? That makes no sense. None at all. Oh, wait a second. What if I try this? No, still same thing. What? This is odd. This is just very odd. And that's not giving anything. Oh, that is dirty as shit. Yeah, that's the right wire. What the where the hell did I go wrong here? Where the fuck did I go wrong? I think I just messed it up. I think it was right the first time. I think I was... I don't know why, but for some reason I was... Yeah. No, it was right the first time. Son of a bitch. Because this is the positive rail. This is the 5-volt rail off of that. Yeah, this goes to there, and then the Zener diode clamps it to 5 volts to ground here. So this is the ground. So that is feeding, and then that goes back to ground. Son of a gun. I am having a winner of a day. Alright, well, here's the thing. The live stream has went on long enough. Not much viewership. I have to fix this thing, so I'm going to go ahead and just go back to the drawing board and fix this thing and put it back to the way it was, because I had it right the first time. Jesus Christ. And, I guess we'll stop the live stream here. We've accomplished a whole lot of nothing, because this is not working well. This is not going well for me. Oh, man. Anyways, alright, thank you guys for watching. This has not been one of our better live streams, but thank you very much for watching. And I'll see you on the next one. Hopefully on the next one, this thing actually works right, because I stopped messing it up. Alright, I'll see you guys. Have a good night.